Hi, in this video, we are discussing the sixth numerical from the chapter for mathematical methods, which is the second chapter for 11th standard physics. So let's get started. Now, it's a to prove question जहाँ पर हमें बताया गया है कि एक statement दिया गया है where we have a function sin x upon cos x and अगर उस function का अगर हम derivative निकालेंगे तो that must be equal to sec square x. That is what we have to prove. नाउ एक मेथड ये भी हो सकता है कि हम साइन एक्स अपॉन कॉस एक्स को लिखे साइन एक्स अपॉन cos x को we represent as tan x, and if we were to calculate the derivative of tan x, it does come out to be sec square x, and we can say hence proof. But this is not valid because question में specifically बोला गया है to use the rule of differentiation or where we have quotient of two functions. So when we were studying the properties of differentiation, हमने एक rule पढ़ा था which we will look in some time in this video. So we have to use that particular formula or rule to prove this particular question. So let's get started with the question. सबसे पहले let us try to write what we have to prove. So we have to prove that basically derivative of sin x upon cos x is equal to sec square x. And let's start with the proof. So first, let us define that we have a function f1 of x and we are denoting that function as sine of x. And then we assume that we have another function, this time it's f2 of x, and let this function be cos of x. And if we were to divide both these functions, so basically if we were to divide function f1x by f2x, we would get the resulting function as sine x upon cos x. Okay, and why did we do that? Well, let's see it. So first of all, when we were studying differentiation, we studied a property where if we were to find the derivative of a term which is a function of x divided by another function of x, in this question, in this particular instance, it is f1 of x divided by f2 of x, then the resulting derivation was derivation of first function divided by the second function as it is, minus derivative of the second function multiplied by a term which was first function divided by the square of second function. So this was the property which we learned when we were learning differentiation for this particular chapter. And if we were to substitute the value of f1 and f2 of x as presented by us in the previous slide where we said f1 of x is sin x and f2 of x is cos x. So if we were to use that over here, we can say d by dx of sin x upon cos x can be represented as 1 upon cos x, which is the f2 of x, into integral of sin x, which is the f1 of x, minus the first function, that is sin x, divided by the second function f2 of x ka square, that is cos square x, cos x ka square, into the derivative of the second function, that is derivative of cos x. Now if we were to solve this further, derivative of sin x is the cos x, so we have 1 upon cos x into cos x, which will get cancelled out. And in the second term, we have derivative of cos x, which is minus of sin x. So if we were to multiply sine of x upon cos square of x into minus of sin x, we get the term 1 plus sine square x upon cos square s, as cos x gets cancelled. So the resultant is 1. Over here, sine of x into minus of sine x gets multiplied, so it becomes sine square x, and this minus cancel each other out. That's why we have a plus. So the resultant over here is 1 upon tan square x, because sine upon cos is tan. So sine square x upon cos square x is tan square x. And if we were to use the trigonometric identity where we know that 1 plus tan square theta is given to us as sec square theta. So if we apply this identity over here, we get 1 plus tan square x as sec square x. Hereby, we have proved that if we were to find the derivative of the term sin x upon cos x, it comes out to be sec square x, and hence we have proved. If you want a PDF of this solution, do check out the description. And with this, I hope it helped you. Thank you.